So today we will be discussing new sum. It is basically example 6 of your book, question number 10, where you need to find the LCM and HCF. So basically you know what is LCM and HCF. Again I am repeating. Okay. So suppose LCM, HCF I have already discussed last class. So check that video if you haven't. LCM means is what? Lowest common multiple, right? Now the question is, how can you find the LCM? So I am going to the basic concept. What is that? Now what is multiple? Suppose we want to find the LCM of say 4 and 10. Okay. So what are the multiples of 4? Multiples of 4 are 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, and so on. Okay. And 10, multiple of 10 is what? 10 1s are 10, 10 2s are 20, 10 3s are 30, 10 4s are 40, and so on. Okay. Now if we go on, 4 10s are how much we will get? 40 we will get. Yes. So what are the common multiples? 20 is a common multiple, 40 is a common multiple, and in this way we will go on. Then we will get more and more common multiples. So common multiple we know, but what is lowest? 20 is the lowest among these two. So LCM of 4 and 10 will be your 20. Understood? Now this is basic. This you will not be using in class 10. Suppose here I am taking the example 6 of your book, where they have asked to find the LCM and HCF. LCM and HCF of 6 and 20. So first you factorize 6, 2 3s are 6, 3 1s are 3. 20 when you factorize, 2 10s are 20, 2 5s are 10, 5 1s are 5. Okay. Now 6 can be written as 2 into 3, or specifically 2 power 1 into 3 power 1, and 20 can be written as 2 into 2 into 5. So that means 2 square into 5. Okay. So when we find the HCF, you remember one thing, when you find the HCF, we have to see first which one is common. So 2 is common in both the cases. Then take the smallest of the power. Which is the smallest power? 2 power 1 or 2 power 2? Obviously 2 power 1. So 2 power 1 and nothing else is going common. So 2 power 1 equals to 2. That becomes your HCF. And when you find the LCM, what you need to do is, what is the common? 2 is common. And what is the highest among these two? Highest is 2 to the power 2. And are they common? No. So in LCM, you remember, you have to write the highest of the common and the uncommon also. So 3 to the power 1 is uncommon, 5 is also uncommon. Okay. So what is the multiple? 2 2s are 4, 4 3 5s are 15. Yes. 60 is the LCM. So this is how you find the LCM and HCF of two numbers. Okay. And there is a relation by which you can find out this. The relation is, note this formula, LCM into HCF will give us product of two numbers. Product of two numbers. That formula you remember, and most importantly, if suppose they have asked you to find the LCM and HCF of three numbers, then you have to do it by this method. Then you cannot use this formula. Okay? This formula is only applicable to how many numbers? Two numbers. You keep this in mind. Okay? Let us verify this. LCM into HCF. Where is LCM? This is LCM and this is HCF. So if I verify this, LCM into HCF is how much? 2 into 60. So that makes a makes it 120, right? And if I find the product of two number, product of two number is what? 6 into 20. That was our number. 6 to the 120. Hence it is verified. Okay. So this is the next type of sums that will come in your exam. Okay. So this method, by using this method, if I find, that method has a name, that is called prime factorization method, that you already know. Prime factorization. Okay. If it is not mentioned, then you can use either this method or this method. If LCM and HCF is known to you, or there are three things, right? Suppose we will consider the two numbers as A and B. So LCM into HCF will give us A multiplied by B. Suppose any three information is given to you, you can find out the remaining one by using this formula. Suppose LCM and HCF is given and one number is given, so you have to find the other one. So you can find out by this formula. Yes. So accordingly, you can do exercise 1.2. Your homework will be exercise 1.2. Question number 1 you can do, 2 you can do, 3 also you can do, 4, 1, 2, 3, 4 you can do. 1, 2, 3 and 4. Okay. Question number 5 and 6 I will explain later. Question number 7. Let me introduce the question to you. What is the question? See, there are circular paths around a sport field. Sonia takes 18 minutes to drive one field, one round, while Ravi takes 12 minutes. Suppose they both start at the same point and go in the same direction. After how many minutes will they meet at the starting point? So this is the question. So there is a circular track. Yes. Two persons are moving from here. This. Same person is moving. So both of them take different times to complete. So the question is, after how many minutes they will meet at the same point. It is not necessary that they will meet at this point or this point, wherever maybe. So this is also keep on running. He is also keep on running. So the maximum time it will take. So that will be your LCM of the two number. Remember, LCM means what? They will not. HCF is what? Minimum values you get. But in LCM we have to get the maximum value. So one takes how many minutes? 12 minutes and another takes 18 minutes. This is 12, suppose this is 18. So the LCM of 12 and 18 will get us the answer. Do you understand why? Because when they go around, that means what? They will not came across immediately, right? They will have some time, they will take some time to take some round and then they will meet at the same point. So that is why we have to find the LCM of 12 and 18. Okay. So this question number 7 also you can do at the homework. Okay. Thank you. So I forgot to do question number 7. Question number 7 is what? Find the HCF of 96 and 404. Example 7 is find the HCF of 96 and 404. So by prime factorization method you can easily find out this one, I know. And they have asked, hence find their LCM. So when you find the HCF of this, hence, when they use the word hence, that means what? We have to find the HCF first, and LCM how will you find? By using the formula that I have given just now. What formula? LCM into HCF equals to product of two numbers. Two numbers are given to you. So that you can do as a homework. And example 8 you see. Example 8 is also similar. Here three numbers are there. 6, 72 and 120. So you have to find the what? HCF and LCM, both you have to find. Okay. Now there are three numbers, you cannot use the formula. You have to go on dividing. So 6, 2, 3 is 6. 3 1s are 3. 72 can, when you divide with 2, 36 are 2, 18 are 2 9s are 3 3s are, and 120 2 60s are 2 30s are, 2 15s are, 2 3 5s are. So 6 can be written as 2 into 3. 72 can be written as 2 to the power 1 2 3. 2 to the power 3 into 3 2 times, so 3 square. And 120 can be written as 2 3 times 1 2 3 and 3 into 5 power 1. So I told HCF is always the minimum. So 2 is common, and which is minimum? 2 power 1 is minimum. So 2 power 1, and 3 is also common. 3 power 1, 3 power 2 and 3 power 1. So which is the smallest power? 3 power 1. So into 3 power 1. So that makes it 3 to the 6. Okay. But when you find the LCM, I am writing it here. When you find the LCM, you keep in mind that the highest 2 2 2 and highest power of 2 is 3. So take 2 to the power 3 into 3 power 1, 3 power 2 and 3 power 1. So highest is 3 power 2. So take 3 power 2 into, what is the uncommon here? 5 is uncommon, so write 5 as well. So 2 cube is 8, 3 square is 9 into 5. So 5 at 40 into 9. So 436. So 360 is the LCM. Yes. So this is how you have to do example 8. So similarly you can find for 3 number and you can find for 2 number. But when there are 3 numbers, you cannot use the formula, you have to use the regular method, prime factorization method. Okay. Coming to the very important part, before going to the important part, let me give you a brief idea. Just see, we have got that what root 2 or root 3 or root 5 is an irrational number. In the first class I have already told. So now the question is, how can you prove? Two types of question will come. One question is, prove that root 2 is irrational. Irrational. This is the first question that comes. And second question I will discuss later. But before going into this, let me explain you theorem 1.3. That is not required to learn, but you have to use the theorem to do this sum. So the theorem says, if P is a prime number. Now I believe you know what is a prime number. The number which can be only divided by the number itself and 1. Prime number, if P divides a square, if P divides a square, then P divides A. If this is true, then we can say that P is divided by A. Now let us consider that P is a prime number, say 2. Okay? Or what will you take? Suppose 5. If you take 5 is also a prime number. So take A as a number. A means say A can be any number, say 2. So it says that if 2 square is divided by 5, then 2 will also be divided by 5. Okay? Or did I say something wrong? No. So 2 square is what? 4. 4 is divided by 5. It is not going. So therefore 2 is also divided by 5 is not going. Divide means the remainder should be 0. Similarly, if you take say A equals to 5 and our P is also equal to 5. So if A square is divided by P, that means A square divided by 5. A square divided by P means 25 divided by 5. So the remainder is 0, that means it is going. Then A will also be divided by 5. If you A divided by P, 5 divided by 5, that is 1. So the question is, how you can apply this theorem in this. Okay? We have to prove this by the method of contradiction. Now what is the method of contradiction? Method of contradiction means we have to assume something and we have to prove that it is wrong. Okay? It sounds little difficult for you because it is class 10 just you have got, but lately you will find it easy. Okay? Did you understand this? If p is a prime number and a is any number, the theorem says if p divides a square, that means if a square is divided by p, then a will also be divided by p. We can see here if a square, that means 25 is divided by 5, that means a will be also divided. So that is why it is divided, remainder is 0 in both the cases. But here 2 square is divided by 5, but 2 it is also not divided by 5, that means you will not get a remainder 0, but here also you will not get the remainder 0. Okay, keeping this in mind, we will start this. How will you prove root 2 is irrational? We have to assume let root 2 be a rational number. Now, if it is a rational number, it has to be written in the form of p by q. So, what we can write, root 2 equals to p by q, where p and q are what? Integers, and q cannot be 0, and p and q are co-prime. Now what is co-prime? That means their HCF, that is their HCF should be 1. That means 2 and 3, their HCF is 1, that is why they will not cancel each other. But if I take 6 and 2, they will cancel, right? 2 1 are 2, 2 3 are 6. So this kind of number they are not considering, this type of number where there is no further cancellation. Okay? So now what will you do? You will square both sides. So obviously root 2 square will be 2. This will be our p square by q square. So q, if you take in this side, so 2q square equal to what? P square. Now what we can write, q square equal to p square by 2. Since, see, the theorem we will apply here. Since p square divides 2, since 2 divides p square, so therefore what we can write, 2 divides p also. Since we are getting that p square is divisible by 2, so p will also be divisible by 2, so that is why 2 divides p also. So if p is p can be divided by 2, that means p is a what number? Even number. Even number can be written in the form of 2 into something. So therefore what we can write, therefore p equals to say 2r, if I take. Now again you square both sides, 2r whole square. So p square will remain same, that will be 4r square. Now instead of p square, what I can write, 2q square. Use this one, 2q square equal to 4r square. If I cancel, so that becomes q square equals to 4 divided by 2 means 2r square. Yes, I am rubbing this side. We will again use the theorem. What theorem? After this, q square divided by 2 equals to r square. So what again we can say, since 2 divides q square, therefore 2 divides q also. Yes. So if see what we are getting, p square is divisible by 2, so that is why p also divisible by 2. Here q is also divisible by 2. So what we can say, that means what we can say here is p and q both have at least 2 as a common factor. Both have at least 2 as a common factor. Did you understand why? Yes? 2, here we have proved that 2 divides p, that means p is divisible by 2. Here q is also divisible by 2. The situation is like that. P by q, if you do what we have taken, they are co-prime, but when they are divisible by 2, so that means it is say 4 and 6. So that means 2 2s are 4, 2 3s are 6, that means both are divisible by 2. But what we assume that their HCF is 1 because they are co-prime. But our assumption was wrong. But what will you write? But it contradicts the fact that A and B are see, there are two types of sums. One is example 10 and 11. Here we have to prove 5 minus root 3 is irrational, and here 3 root 2 is irrational. Okay? Same approach you will do, but here there is a shortcut, there is a trick. What? We have to assume that root 3 and root 2 are irrational. We have to prove this whole number to be irrational. Yes? So, similarly, we have written that. So, your aim will be, your agenda will be, keep root 3 or root 2 in one side and keep everything aside. So, if I take 5 minus p by q, then it becomes root 3. So, if I take q here, so that means 5q minus p equals to root 3, and root 2 I am keeping here, so that means p by 3q. Now, what did we assume? P and q are co-prime, that means there are some integers. So you consider 5 is an integer, integer multiplied by integer, that means it is an integer. It is also an again integer, so integer minus integer is also an integer. Now integer divided by another integer, 5 divided by 3, that makes it a rational number. See, it is in the form of p by q. So that means what we can write, since 5q minus p by q is a rational number. Why? Because integer minus integer divided by integer is a rational number. But we know that root 3 is irrational. So since root 3 is irrational, but this is showing rational, that means what? Our assumption was wrong. Our assumption was wrong. Since our assumption was wrong, that means what? This whole number we have considered to be a rational number. But since our assumption was wrong, so therefore we can write 5 minus root 3 is irrational. Simple. Similarly, that much you can do. Since p is a rational number, integer, q is also an integer. So integer divided by integer will be a, this will be a rational number. Same way you will write, this is a rational number. But we know root 2 is irrational. So our assumption was wrong. So therefore 3 root 2 is a irrational number. Okay. So similarly you will do question number example 9, 10, 11. Homework will be exercise example 9, 10, 11 and exercise 1.3 all. Okay, that much you can do. Thank you.